Okay, in this video I'm going to do this problem here about the functions f1 through f9 defined in this table, and they each map the set A onto itself. In other words, for each of the functions, for I equals 1 to 9, we can say that f of I maps the set A onto itself. Okay? And it asks which are one-to-one, which are onto, and which are bijections. Well, for example, F1 maps each of the elements A, B, and C to the element A. Okay? And F2 maps A to A, B to A, and C to B. And we can write several of these things. For example, I could write F2 of A is equal to A, F2 of B is equal to A, and F2 of C is equal to B. These are derived from this column of the table. So that's what this table means, and this defines 9 different functions. And when we look at a table like this and ask whether or not a function is one-to-one, we're looking for the case of no repeats. Okay? And so one-to-one means no repeats in the column that defines it. Okay? And what that means is that, well, it's very easy to tell then. One-to-one, the functions that are one-to-one functions, you can just scan across here and see. Here we have two A's, here we have two B's, here we have no repeats, so F6 is one-to-one. Here we have two A's, here we have, F8 is one-to-one, and here we have two C's on 9. So F6 and F8 are one-to-one. No repeats. Okay? When we look for an onto function, we look for every element of the range being in the column. Okay, of the range is in the column. And it turns out the same two are onto. And bijections mean that it's one-to-one and onto. And it turns out then that exactly the same two, F6 and F8, are the bijections. And so it turns out, and this is generally true, that whenever you have the domain and the range with the same size, whether it's mapping the same set to itself or not, but whenever the domain and the range are the same size, one-to-one and onto and bijections all end up meaning the same thing. Okay? So that's the solution to this problem, number 1 here.